All right. We're locked out of our own video. But this video is going to be great. We are going to be building a computer inside a mini fridge. We are going to answer the question once and for all. Is it a good idea to build a computer inside a mini fridge? Like the video if you think that's a good question to answer. I didn't have any other teasers ready. Okay, I need a key. Corsair delivers real mech, oh, here I have one. Ha! Real mech or nothing with their new Strafe mechanical keyboard featuring genuine German-made Cherry MX key switches. Click on my chin to learn more. I'm gonna move my chin now just to throw you for a loop. This may not look like a computer case to you, nor does it look like a computer case to me, because it's not a computer case. This is a fully functional, that is to say, working but not plugged in, mini fridge. And if you're like me and you've trolled many a forum, you've either witnessed or come up with the idea on your own of building a computer inside a mini fridge where, well, hey, it's cold in there. Must be great for overclocking, right? Let's put it to the test. Do you even lift, bro? Yeah, I lift. All right. Okay. Now, before you go full bore on any kind of project, you want to at least validate the concept. So we'll be taking the Zotac ZBox Pico PI320, and we will be experimenting to find out if this compact and power-efficient, passively cooled PC can actually experience an improvement in thermals and or performance inside the mini fridge. Right, but of course first we have to establish a baseline reading in our ambient temperature test here. So we're booting up the ZBox and then we're gonna run a stress test to find out just how she runs before putting her inside the fridge. All right, so we've got our baseline numbers. We're looking at anywhere from about 46 to 49 degrees Celsius on our cores, which puts us at about 22 to 25 degrees above our ambient temperature, which is about 27 degrees. Now, let's go ahead and fire up a stress test.
What is that?
That's weird.
What is that noise?
My backpack here.
What's going on?
Shut up!
It got louder. Oh. Okay. Maybe that's the. Maybe it's the low battery alert.
That is a pretty aggressive low battery alert, and yet.
Apparently that's what it is.
Apparently that's what it was. Okay, so with that crummy experience out of the way, it looks like our CPU temperatures have settled in to 59 to 63 degrees, and our ambient temperatures are actually a touch higher at 27.5. Okay, so what we'll find out now is whether our fridge is even ready for us to put our system inside it. I thought it's supposed to be like 4 degrees. Maybe that's a touch hot. Oh, well then it is going down very fast. Okay, so let's go ahead and put this puppy on the shelf. Then let's start it. Boom. Okay, so no real surprises here. Our idle temperature test gives us anywhere from 25 to 27 degrees. Our ambient temperature around the Pico is around 5 degrees, and that stands to reason because we're looking at about a 20-degree delta between ambient and CPU temperature. So that means that at idle, the mini fridge works. It cools the Pico. So this is the part where the video gets really interesting. Our fridge's compressor is running all the time, but it is maintaining a frosty internal temperature as low as 2 to 2.5 degrees Celsius, and our CPU has settled in at around 38 to 40 degrees Celsius under load. The mini fridge concept is a massive success, achieving a, let's see, wow, greater than 20-degree improvement in load CPU temperatures. Now we're gonna take things up a notch. I'm gonna steal Luke's test bench and find out if the type of rig that you would actually benefit from cooling down for better overclockability will actually work in our mini fridge setup. So this is a Titan X. This is a 5930K or 5960X, not sure which. 16 gigs of DDR4 memory. Let's go. He'll never miss it. Actually, he'll come looking for me. So now it's baseline time with Luke's rig here in the garage. So our ambient temperatures are a little cooler than yesterday, but that's okay, we can correct for that. The most important thing is the difference between ambient temperature and CPU temperature when you're measuring this sort of thing. And our CPU temperature, we're gonna simplify things a little bit. Instead of looking at all the cores, we're just gonna take the CPU reading, and we're looking at it's fluctuating between 29 and 30 degrees. So now, let's start the stress test and see where we end up outside of the cooling box. We have our numbers. So the room cooled down a little bit thanks to some breeziness at about 22.5 degrees, and our CPU settled in just under 45 degrees on the hottest of its 6 cores. It is a 5930K. I have now confirmed that. So now it's time. Let's do it. Go ahead and start by removing some shelves. I do not recommend cooling down hard drives, especially while they are operating. So we're not going to be putting our hard drive in there. And another thing, this Pico, now that it's cold and it's below ambient temperature, should not be powered on until it reaches ambient temperature on its own, because otherwise condensation can be a factor, and any moisture with powered on electronics is a terrible idea. Okay, I think we've actually got enough clearance on our fans here that they should be able to cool the CPU just fine. There's a bit of a problem here. I have a solution. There we go. Problem solved. So we're getting ambient temperature readings, the compressor is running, and we can see our idle CPU temperatures here. So let's find out where she settles in at idle. Bear in mind, guys, that we are talking a very different level of heat load here. I think the Pico has a power supply that's something like 10 watts total, whereas even at idle, this computer is going to consume somewhere in the neighborhood of 80 to 90 watts. Now, I was really hoping, I was rooting for it. I was hoping that the idle scenario would give us sub-ambient temperatures, but in fact, it has settled in around 23.3 degrees, almost exactly the ambient temperature of the room, which means we're basically achieving nothing other than consuming electricity by putting the computer inside the fridge. But I promised you guys a load scenario, and that is what I am going to deliver. It should be noted that I observed that to the touch, the side of the fridge, which is where this particular unit seems to dissipate heat from the hot side of the HVAC unit, is hotter than I have experienced before. You can see we actually just crept up another fraction of a degree, so we're at 23.4 right now. Let's go ahead and kick it into high gear, kids. Okay, so you can see they've already jumped to about what we observed in our outside control test. But what this doesn't account for is that the ambient temperature in here is going to increase now that the compressor and refrigeration system inside here is overwhelmed. So let's watch it happen, shall we? All right, so this is taking longer than I thought to completely reach unreasonable temperatures, and here we are, 12 minutes later, the system is still running, but we know enough to know that it doesn't work. This is not even an overclocked rig, and our ambient temperatures inside the fridge are steadily climbing. I took a reading about 30 seconds ago. It was 26.5. Now it's peaking at 27, depending on how I jiggle the probe. So all that's really left is the explanation for why this doesn't work. Well, there's no airflow. This is a closed system. So this system relies on itself to move any heat that's generated inside out. So that's going to be done through the sides of the unit, or in many cases on fridges, a coil at the back, a heat sink effectively. So unless you're using a unit with enough capacity to handle not only keeping the insides cold, but also removing a constant heat load, it isn't going to work. So we can't just introduce airflow by punching fans in the side. So a closed system depends on the capacity of the system for cooling. Now, with that said, you guys might go, okay, well, hold on a second, Linus. You showed off that the low-powered PC could work, and even the idle PC was not failing at the rate that the load PC is. Well, that's only sort of true because fridges are designed for occasional use. Some heat from the outside will transfer inside through the insulated barrier, and it'll have to, maintain that. Also, the user will open it up from time to time to remove a drink, so the compressor fires up and it gets things back down to a nice cool temperature. They're not designed with components that are rated for 24-hour, 7-day-a-week operation. That type of workload rating is only going to be found in a more industrial unit, something like an air conditioner. And I guess that's where we get into the practical sort of side of phase change cooling for computers. If you have a large, high-capacity air conditioner, say for example designed for a room that can handle that kind of a heat load, or something where an entire building is air conditioned, then you will get the benefit of the lower ambient temperature, not only for yourself, but also for your computer. Also, if you checked out our phase change BC build guide, which you can check out in the little eye in the corner, well, if you apply the phase change cooling directly to the heat load and you're controlling the scope of what you're cooling, we haven't even fired up the graphics card in here and we're overwhelming it, then it can be useful as well. But again, we're talking high-end components, not a couple $100 mini fridge, and we're talking custom designed stuff, in that case from LD Cooling. So yeah, I mean, most of you probably knew how this was going to turn out. Some of you might not have, because it's all about how you think about it. If you think about your computer in terms of that it runs at 30 or 40 degrees, and so, it should be able to be kept cool, then I get where you're coming from, but it's more to do with the total thermal energy, not the actual temperature, which are two completely different things. And if you think about it this way, a computer that consumes, 300, 400 watts at load is going to be kicking off basically equivalent amounts of heat. That's about the same as a modest space heater. And you wouldn't think putting a space heater inside a fridge would keep that cool either, would you? So there you go, guys. The answer has finally been provided online as Tech Tips, not that anyone else hasn't ever proved this before. You can see in the time I've even been talking here, we've gone up almost an entire additional degree. So I'm gonna go ahead and put this system out of its misery now. Thank you for watching. If you disliked this video, bam, you know what to do. But if you liked it, then go ahead, click that like button, get subscribed to our videos, even consider supporting us by buying a cool t-shirt like this one, shopping on Amazon using our affiliate code. We've actually got a video guiding you guys through how to do that, or even by supporting us directly through the Linus Tech Tips community. If you guys are looking for something else to watch now that you've done all that stuff, I'm gonna pull up my calendar and find out what I've done recently. Yes, Luke should have just uploaded the Doomhammer machine, where we built the ultimate possible machine out of all the components in our office and ran it through the gauntlet for you. So check that out. I'll see you guys again next time.